Hello students, so in this video we will solve P3 May 2024 paper. So this is one of the recent papers for P3. So we will try to solve this whole paper in a detailed way, and I will try to explain as much as possible in this video. So basically this video, it will consist of only the first question. So I have planned to make videos on each of the questions separately, so that you can it will be easier for you to see the solution videos which one is according to your necessity. Okay, so for P3 2024 paper, the first question was from modulus functions. From modulus functions. Okay, so this is basically from chapter number 2 of your P3 book, modulus functions. Okay, so let's see what they have said in question number 1. Okay, so there you can see figure 1. This is a sketch of modulus function given. Okay, so figure 1 shows a sketch of the graph with equation y equals to f of x, where f of x equals to twice of x minus 5 modulus plus 10. Okay, we got the modulus equation. Fine. So the point P shown in figure 1 is the vertex of the graph. Okay, we can see point P there. This is the vertex, the minimum point of the modulus graph. Okay, so state the coordinates of point P. Okay, so we need to tell the coordinates of point P. Okay, so basically if you see the equation of the modulus function, this is twice of x minus 5 whole modulus plus 10. So see the modulus part, it is x minus 5 whole modulus. So basically the function, the modulus function f of x, it is transformed. How is it transformed? If you see the graph of x minus 5 whole modulus, its graph would be like this. Its graph would be like this. Okay, so basically they multiplied this, they stretched it along the y-axis by twice. Okay, and then they translated it along the y-axis by 10 units along the positive y-axis, and that's how the point P came to here. So initially it was at this point. At this point the x value is what? Okay, sorry, the x value is here. It's x equals to what? 5. We got the x coordinate of point P. Since it is just having vertical transformations, so the x coordinate of the vertex will remain as it is. So the x coordinate is what? It's 5. And what would be the y coordinate? Here the y value is 0 for the graph of what? Y equals to x minus 5 modulus. For the graph of x minus 5 modulus, the x value is 5 and the y value is what? 0. So 0 times 2 is what? 0 plus 10. So just it will be the y coordinate of point P would be plus 10, positive 10. Okay, next, part B. What they have asked in part B: use algebra to solve this inequality. Okay, so at first consider, this is the modulus function, the graph. We can see this, the sketch of this modulus function in figure 1. But what is this? 6x. So this is straight line y equals to 6x. Now let's try to sketch this straight line in here. What you will get? Y equals to 6x. The gradient of this modulus graph is 2, and the gradient of this straight line is 6. That means it will be more steeper. So that means the straight line would be passing through the origin definitely, and it will go like this. Let me elongate this one. So it will pass through the origin 6x. Okay, it will be like it will be not parallel. Okay, So the graph would be like this. So since it is steeper, so definitely it will intersect the curve at only one point, definitely. Okay, so this is the what sketch for y equals to 6x, y equals to what 6x line. Okay, now they wanted what y equals to 6x. 6x should be less than, that means the straight line, we need to find out the values of x for which the straight line 6x will be below the modulus graph. Okay, so let's see which part is below the, like, for in which part the straight line is below the modulus graph. You can see this is that part, these parts. Let me change the color. This part is below the modulus graph. So we need to find out the critical value at first. You know, definitely for solving any inequality we go for at first the critical values. So at critical values it should, okay, so at first critical values, what would be the case? Twice of x minus 5 plus 10 would be greater than 6, would be equal, sorry, it would be equal 6x, since we are finding critical values. So now we know that if you take out the modulus, there are two possible values, either positive or negative. So which one we would consider? It depends on your sketch. Look, you can see that the y equals to 6x, this straight line, it is intersecting the negative gradient. Look at this part, the modulus graph is what? Decreasing. Let me erase the previous graph. Okay, so if you see y equals to 6x, this straight line, it is intersecting the negative gradient of the what? Of the modulus graph. So that means we will equate the negative gradient. So we will consider the negative 2x plus 10 plus 10 plus 10 equals to what? 6x. Okay, so 6x plus twice of x is what? 8x equals to what? 20. So what would be the value for x? The value for x would be 20 over 8. This is nothing but 5 over 2. This is the x coordinate of the critical value. Now with respect to that x value, we will set the range of values of x. Let's see. So it should be what? Below. It's less than, right? It's to the left, that means it should be less than. So that means the solution would be what? So the solution to this part B, it is what? X less than 5 over 2. This is the range of values of x for which the straight line 6x would be below the modulus graph f of x. Okay, so the last part of this question number 1, part C. Find the point to which P is mapped, that is to which P has been transformed to when the graph with equation y equals to f of x is transformed to the graph with equation y equals to f of x 3 times f of x minus 2. Okay, so at first consider the coordinates of point P. What was the coordinates of point P? It was what? 5, 10. Okay, so now see the transformation, like what type of transformation happening there. F of x minus 2. At first consider the horizontal transformation along the x-axis. This is f of x minus 2. That means f of x minus 2, we know that along the horizontal axis the opposite thing happens. The opposite thing happens. Yeah, so we know that along the x-axis the opposite thing happens. That means it is x minus 2. That means point P has been moved towards the positive x-axis by 2 units. So the x coordinate of point P would be added by 2. That means it would be now 7. Now consider the vertical transformation. It is just 3 times. What is multiplied outside the bracket? This is 3. The constant is 3. So 3 times the y coordinate of point P. This is what? 3 times 10. So that would be what? 30. So we got answer for part C. What would be for part C? it is 7, and 3 times 10, this is what, 30. So this would be the point at which point P will be mapped to according to the transformation mentioned in the question C. That's all about question number 1 from May 2024 paper.